Hi, this is Jeremy Ashlock with Handy Geotechnical Instruments, and going to go through training on setting up and using the Automated Borehole Shear Tester. So I'll go through setting up the equipment, preparing the borehole, and performing the test, and then I'll take some video of the screen of the computer and some explanation of the program as we run through a test. So first you have your electronics case here, the orange one. As you open it up, you'll notice you have several cables in here. There's USB cables. There's two USB adapters. This is a special USB cable that's kind of hard to find just by walking into Walmart or something. You usually have to order these online. But both ends of the cable, and there's two of them, are this rectangular USB male A. And then you can get this adapter here at any Walmart, but it's just a USB A to USB C because the tablet we're using has USB C cables. So you'd think you could buy just a normal cable that has USB-C on one end and this USB-A on the other. However, those don't work. There's some kind of gender changing that goes on here, and these ones you need to have this adapter here. So two of these, and then each one of these is just going to go into one USB port in the Surface computer. So you have two gray cables here, multi-pin cables, one large, one small, so you can't get them wrong. It may help to kind of notice that the pins start at the top. So for the big cable, it's 2 on the top, and then 4 in the next row, and then 1, and then that's up. So when you go to line it up, if you have it aligned that way, you'll know that it's going to go in right. Otherwise, you put it on, you kind of spin it until you feel it click, and then it's real important to get these to engage all the way, or your pins will not be plugged in. Basically, the program will not see the electronics, and it will think the stepper motor is not working, or that the pressure controller is not working. So you rotate these, you kind of feel a definite click where they lock in. So I'll show you that as we're going through the test. Then power cable. Make sure to use a good power supply, ideally wall outlet power, but of course in the field you don't have residential or 120 volts electrical power from a building. Then the next best thing is to have a pure sine wave inverter. And if you don't have a pure sine wave inverter, if you have a cheap generator, if you put the generator's power line on a scope, an oscilloscope, you look at this time history, it's going to be really noisy, and it's going to show up as noise in your data. So you really want to get a clean power, and the best power is a pure sine wave inverter. We've also run 12-volt marine batteries, either one of them or two of them hooked up in parallel, running a pure sine wave inverter, and that would be totally silent if you want the silent option rather than a generator running all day. But you do have to have clean power. Okay, the last cable here is just a coaxial cable with BNC connectors. Be a little bit careful of these. They're just crimped. They can kind of come loose if you're really rough with them here on the ends, so you don't want to bend them too much on the ends there. These cables all have these cable wraps, which are Velcro. It's kind of nice to make these a little loose. Don't have them so tight that you can't slide it up and down the cable, because once you get the cable wound up, usually your thing is over here, and you want to gather the cable here so that you're closer to both sides of the ends so that they're not flapping all around. So having this loose on here allows you to slide it around. It's a lot more convenient. That goes for all the cables here, the USB cables as well as the multi-conductor cables. So power here, I'm going to take that goes and plugs in. You've got two USB cables over here, and these are going to go to your tablet. It doesn't matter which order they're in, just that you have both of them plugged in. Of course, USB-A was not bi-directional. You got to figure out the right way to put it in. USB-C, this one, they finally got smart. You can plug it in either way and it works. I usually like to get these cables out of the way in the back. And I like to try to keep the data cables away from the power cables, or at least crossing at 90 degrees, just minimize noise. Stepper motor, there's a power switch here on the case. Let me see if you can see that. Yeah. So this could cut the power to the stepper motor. Say something is wrong and you want to run a test manually by putting on the hand crank and turning it by hand. You can kill the power to the stepper motor, and you're able to do that. Otherwise, if the stepper motor's on, it's going to be holding the motor at one spot because it wants to take over and control it, and you won't be able to turn it. Sometimes for troubleshooting, this also helps to power cycle the stepper motor. Just flip it off and then on, and then it should report itself to the program. The program should be able to see it. So I'll continue hooking up these cables here. This smaller diameter one here on this end is going to go to the pressure control panel here, and I was very lucky that one just plugged right in. You see 3 on top, 3 on bottom. If not, kind of rotate, find where it fits in, and most important thing, make sure it's all the way secured. Some people have lost, a half-day testing just to figure out that the cable wasn't plugged in all the way, and you didn't get that locking by screwing it all the way in. Especially for this bigger one that goes to the stepper motor. So these ones, you've got some distance here if you need to get away from the hole and get to a vehicle or have this in a truck. On a hot day, it's best not to have this electronics case in the sun. We do have a temperature controlled fan on it here that will, when it gets hot enough, it will kick on. There's an inlet fan and exhaust fan. It'll blow air through the case to avoid overheating, because the electronics, if they're too hot, they do not like to function. So here, I'm looking, pins are on the top, line that up, the 2 on the top, then I'm not searching, and make sure it's securely fastened. This bigger connector is going to go to the base plate where we measure the shear stress and put the pulling rods through on top of the borehole. The last electronics thing is this BNC cable. This carries the signal for the base plate pressure transducer that will let us determine the shear stress. And this, if this was this wire was inside this cable that goes to the base plate, this has noisy signals going to the stepper motor that are sort of digital on and off, and it makes a lot of noise for this really small signal from the pressure sensor. So this shielded cable being separate from these really helps minimize the noise that you see on that sensor. So this will go down to the borehole at the shear plate as well, along with this big connector. So we'll leave some room for those. I'm going to have a borehole over on the other side of the table here, and then this BNC just plugs into here. So for the base plate, this is your good, your data signal. So try to keep this away from power cables or cross at right angles if you can. So like when these are coiled, I like to kind of have a separate coil for the BNC cable, separate coil for this gray multi-conductor cable. So we'll move over to the pressure console case here, but there's room for your Microsoft Surface tablet here, and there's also a courtesy outlet here. If you're in the field and you find you need to charge your laptop, you can go ahead and plug in right here. So the charger for this Surface is not the best design. You have to really make sure that it goes in there. It's really common to just put the connector here, push it in, and it's inside this rugged outside case. So you think it went in, but it didn't actually go in. So you got to really check the alignment. Make sure you push it in. The light will go on, and it has some recesses here for the cable to kind of come out, but sometimes that gets pulled out. You just got to keep your eye on it that the light is on. Sometimes if it doesn't want to charge, you can flip the cable over. It goes bi-directional, and it'll get it to charge that way. So there's that. I got enough charge here that I'm going to probably just use battery power for the tests, and your electronics would be set up there. So now we move over to the CO2 console. And so you've got 10 half-meter pull rods here with marks at every 5 centimeters. We're probably just going to use 1 or 2 here. We'll do a shallow test at maybe 12 or 18 inches depth. Let me move the camera here, get a little closer view. So here you have the normal stress gauge. It's got the gauge factor on here, and it's got actually a new printed dial face. So originally this was a 300 psi pressure gauge, but that's the CO2 pressure in here that acts to expand the shear head, and then that force is applied to the soil, but it's transferred through the shear plate area. So you have the force expanding divided by 1 shear plate area, which is 5 square inches. Just 1 shear plate because it's the same force acting on both sides of the borehole. That force divided by that 5 square inches gives you the normal stress. So we've actually already calibrated this and printed a new dial face, so now this reads directly in soil normal stress. So you have up to 500 kPa of normal stress. Should be plenty for testing most soils. If not, you can use your high pressure shear plates, in which case you would multiply these values by 6.25. You just have to do that in your head, or else later when you get the data file you can do that manually. So what's inside the case here, you have the base plate assembly, you have the shear head here with a bungee cord kind of holding it from falling out, and then a CO2 tank. First thing you want to do, remove the CO2 tank, and it's a good idea to have these pressure lines kind of secured so they're not flopping around and these things are not going to smack into this glass case here. Good idea to have this gauge always covered with the metal cover so that nothing smashes into that and breaks that glass. And then that gauge also has a custom printed dial gauge as well. Reads directly in soil shear stress in kPa. So you'll see in the program it says EU. Everywhere it says EU, that's engineering units. And that's so the program can be general, and you could be PSI or it could be kilopascals. So nowadays we make all our units in kilopascals and SI units, so everywhere you see EU in your data or in the program, just convert that to kilopascals in your mind. Okay. We'll take out the shear head here, maybe retain this bungee cord here just so it doesn't get lost down there. Sometimes it comes off, you have to just reach down and secure it to the end of this PVC pipe that holds the shear head. Sometimes the shear head won't come out. There's like a screw in there. Just got to rotate it a little bit until you lift it out. Shear head, when you're done testing, you always want to clean it off, usually with some water. There's a small wire brush in here to help you clean off the teeth. You want to do that in between tests, get all the soil out from the previous test. Start with a clean interface to go test your new soil point. And then it's a good idea to spray this with WD-40 after a test is over. So here's this is called the hanger, and the pull rods will attach here, go up to the top of the borehole, and then here's the shear plates. So one of these is 5 square inches, and you attach these pressure lines. And I'll give myself a little bit of room to get to the borehole, and I'll keep the rest of this kind of tied up. So attach, and maybe we'll go around the back here, make things a little neater. There's one of these lines that has a black on it, so that is for the retract. That goes in black, and it says right here on the case, on the console for the CO2 unit, black. So plug that in. The one without any black on it, just a white tubing, pressure tubing, just plug that one into white. So that way when you turn to expand, pressure will go through the white. When you turn to retract, pressure will go through the black, and the shear head will expand and retract. Okay. Get a close-up here. So there's also a manual and auto switch here. So manual's here, auto's here. If you were to do a manual test by yourself, you could just once you get CO2 pressure applied with this tank, you can just crank up the pressure on the regulator, read what the normal stress is here, expand pressure is what you would want, and you could go and attach the hand crank and do a manual test by yourself. We'll be doing an auto test, so we'll put it in auto. But one word about that, if I turn on the electronics over here and then I connect this pressure cable here that carries both the command signal to tell it what normal stress to apply, and also there's a pressure sensor under here to measure what this pressure is and report that to the program. If I plugged it in, it would see 0 volts and it would try to give you 0 pressure, 0 psi. So it would actually just start bleeding off the pressure from your CO2 tank, which you don't want. So if you're on auto mode and the power's on here and the cable's plugged in, it's going to try to basically bleed off, give you 0 pressure. So to avoid that, you can either just kind of unplug this cable here if you are for some reason turning it to manual mode and you want to, say, retract and hold the shear head in for a while. Otherwise, what I do is I just do a quick retract and then adjust the pressure down and then go back to auto mode so I'm not losing a lot of pressure, and that way the shear head should be retracted. You can get it in and out of the borehole. If for some reason you need to hold it under retract, like say the shear head's not fully closing, then just unplug this and you'll see it'll stop bleeding off the pressure. But we can show you that as we go through the test. So let's go ahead and take out the base plate here. And I'm going to set that over on the ground. We'll prepare a borehole, and I'll also show you the CO2 tank here when we want to start applying pressure. So since we're here, let's go ahead and do that. So CO2 tank, you want to probably take this out. It makes it a lot easier to get the plate out and maneuver it. Just be real careful about these. You know, don't leave them in a hot car. Kind of keep them shaded, and these are going to be shipped unfilled. You just have to go to any sporting goods store that does paintball cylinder filling, and we can get it filled for about $6 here in town, and they just weigh basically 20 ounces. Give you 20 ounces worth on the scale, and you're good to go. You usually have a couple of these. It's good to have a backup, or you could rig up an adapter to give you a larger CO2 or nitrogen tank if you want to. So I'll keep that valve off for now, but anytime you're trying to take this off, you have to bleed the pressure off this hose first, and we'll show you how to do that later. But if you're trying to unscrew this and you feel some resistance, then there's kind of pressure in the line, and so you got to be careful. You know, it's going to pop off, especially if it's really hard to turn. You want to stop. In that case, you want to bleed off the pressure. And here, like if I try to crank it up, manual mode, okay, I see a little bit of pressure there on the gauge, right? So even though this is fully retracted, there's a pin here that pushes down this tank here to open it up. It's actually all the way left, loose, lefty loosey, righty tighty. This is all the way out. There's still a little pressure, residual pressure in this line. So if I operate a few times, expand and retract, let's see, where's my shear head? Oh, it's over here. So expand and retract. You can see it's operating here. Expand, retract, and I'm kind of bleeding that pressure off that way. You can also plug in a dummy connector that's not connected to a tube, and just crank up this regulator here, and as long as your tank is off, then that will go up and then it bleed off that pressure that just exists in this line here. So that's a good way to bleed that off. So now I have no pressure there. All right, I'm trying to expand, retract. I have the regulator cranked up. There's no pressure, so now it's safe to unscrew this. So let me show you that. Point this away from you as you're doing this, but I can feel there's no resistance there, so there's no pressure. It's safe. Right? Get that filled at your sporting goods store that does paintball, and should be good for a day or two of testing. So I'm going to screw that in. We'll come back to that, but let me take out the base plate and we'll get that set up. So just push these in, pull the pins out, and I would not lift up by this cross plate here because that's just connected to these cylinders here, and what you would be doing is pulling on these pistons and kind of putting them under suction. I always try to support either by right here or just underneath the plate, rather than just grabbing this thing and lifting up. That's our sensitive measuring part, so let's try not to do that. So it's a little tight in here, but you maneuver base plate out of there, and you can put this down where you're ready to drill a hole. And what we'll be doing is connecting that larger multi-pin conductor cable. You see here it's got the two on top, and on the side here, this is your BNC connector for this pressure sensor here, which is basically another measurement of this shear stress here. So it gives us a digital way to read that. If you ever have to do a manual test, we have a hand crank in the case that you can plug on here. As long as your stepper motor is turned off, you can crank this away. It's going to raise your rods, and you'll start to see your stress increase. Just read this gauge manually and note the maximum pressure. That's if you had to run a manual test for some reason. Say you lose power or electronics aren't cooperating. We designed it in such a way that you can always do a manual test. Normally you won't have this handle on here, and if you are reading these gauges, they're mirrored on the outside, so to eliminate parallax error, close one eye, put your eye directly over the gauge, and you want to line up its reflection under the needle with the needle itself, and when you see that it's on top of its reflection, then you're eliminating the parallax and you're reading the correct reading there. So this, in case of emergency, manual hand crank, hopefully you never have to use that. secure the CO2 tank back in here. Good idea to have this, out of direct sunlight. I've got a fire extinguisher bracket in here, just in case something goes wrong, that this doesn't launch off somewhere, and it can be secured in the case here. Be careful of the other end of this. If you ever plug or unplug this into the quick connector that's under this regulator, just want to really be sure that's on, because if it's not, it will pop off under pressure. There's a green plastic thing here. That's the electro-pneumatic pressure regulator. Be careful not to bump that or hit it. It's fairly expensive and fairly sensitive. It has some tiny little resistors to adjust the gain and span if anything gets out of whack. We want it to be adjusted so that it agrees with this gauge here, or really we want it to agree with the pressure sensor inside. So it's already been calibrated by me. So I run through 100, 200, all the way up to 500 kPa, adjust the span and the 0 to get them to agree as close as possible. If there's a little difference here and what you requested, that's not a big deal. Like say you wanted 100 kPa and the program goes up and you see like 95, 98. That's okay, because we're going to measure what the actual pressure is with a pressure sensor, and in the program it'll say, okay, your average stress, normal stress during that test was 98, and so you'll use that value for your plotting, so it'll be fine. This gauge, just kind of a sanity check, or if you were going to do a manual test, then you might adjust the pressure here and watch it change over here. So I'm going to retract or decrease this to 0, fully out, turn this to retract, and I'll go ahead and prepare the borehole and then I'll show you that later.